Hi guys, this is Prashun again. Today we will discuss the third series of logarithm, and here we will discuss how to do the change of base, and we will all together summarize all the formula of logarithm, as well as we will discuss another important topic, that is characteristics and mantissa. So this will complete the theory portions of logarithm, and after that we will discuss the problems and solutions from the next series. Okay. So let's proceed. What is a change of base? Let's say we wanted to find the value of the expression log 50 to the base 2. Now we know 50 is not a rational power of 2, like 2 square equal to 4, 2 to the power 4 equal to 2 into 2 into 2 into 2, that is 2 to 4, 4, 4, 4, 16. But somehow if I multiply, if I put any power of 2, like let's say 2 to the power 8 also, 2 to the power 8 means 2 into 2 4, into 2 8, into 2 16, into 2 32, into 2 64, into 228, into 2 256, but I am not getting somehow the power 50 in this example. So 50 is not a rational power of 2, so it is difficult to evaluate this without a calculator. Even in the calculator you will face problem, because calculator gives either log to the base 10 or ln, that is log to the base e. So directly you cannot put 50 log 50 to the base 2. So only scientific calculator is needed for finding log 50 to the base 2. So there is a theorem which is called the change of the base. How we will achieve these things? Let's say change of the base formula tells like log a to the base b means equal to log a to the base x divided by log b to the base x. So I am just putting the main log with some base divided by the base as a log to the base, that same base. So basically I can see a is going in the numerator and this b is going in the denominator, and x is coming as a base. So this is called the change of the base theorem. Let's see how we can evaluate now log 50 to the base 2. Before that, there are two important notation of this theorem. When using this property, you can choose to change the logarithm to any base x, so that x can be e, x can be 10, anything. As always, the arguments of the logarithm must be positive. The bases of the logarithm must be positive and not equal to 1 in order for this property to hold. So it cannot be 1. If your goal is to find the value of a logarithm, change the base to 10 or e, since this logarithm can be found out through calculator. Let's say log 50 to the base 2, I will put the change of base to 10. Then how it can be? Then we can see by with the above formula, like log a to the base b equal to log a to the base x divided by log b to the base x, equal to b equal to base equal to 2 and a equal to 50 and x equal to 10. X is the change of base. So log 50 to the base 2 equal to log 50 to the base 10, that is one base, and with the same base I will put log 2 to the base 10. That means log 50 divided by log 2. Log 50 I can find out through calculator, log 2 I can calculate through calculator, and this becomes 5.644. So it becomes much easier. We do change of the base. I hope the example is clear. Now we will discuss all logarithm properties at a nutshell, so that it can be used for your exam purpose. If b, a and c are positive real numbers and n is a real number, then the formula, first one is product formula, that is log ac to the base b equal to log a to the base b plus log c to the base b. So the multiplication thing has been come into the summation. Next one is quotient, log a by c to the base b equal to log a to the base b minus log c to the base b. It will be minus. It is a printing mistake. So basically that is the quotient formula. Next one is power formula. Log a to the base b to the power n means the n comes in the left hand side, and this n comes in the left hand side, and then the logarithm. Log 1 to the base b, any log 1 of any base, that becomes 0, and log b to the base b, if the base is same as the log, then it becomes 1. So this is also true. Next one is inverse one. In the inverse one, it is something like that: log b to the base b to the power n, then n is coming, and log b to the base b means 1, that we already know from here. And another one is log b to the power log n to the base b, that becomes n. So that you have to remember. Next one is log a to the base b equal to log c to the base b. If both the bases are equal, the logs are equal if and only if a equal to c, because b equal to b is the base. A and c, if both are equal, then only log a to the base b equal to log c to the base b. And the change of the base, log a to the base b equal to log a to the base c divided by log b to the base c. Now log a to the base c means log a by log b, and log of, if the base is e, then it can be ln a by ln b, or it can be, if the base is 10, it can be log a divided by log b. So these are all the formulas of logarithm. If you remember this, it can be easier for you in the joint entrance examination or in your board examination. Now let's proceed with the characteristics and mantissa. First we will discuss what is characteristic and what is mantissa, and then we will give the example, then that things will be clear. The logarithm of a number contains two parts, namely characteristics and mantissa. Characteristics means the internal part of the logarithm of a number is called its characteristics. Case 1, when the number is greater than 1, at that time the characteristics is 1 less than the number of digits in the left of the decimal point in the given number, that I will see. And case 2, when the number is less than 1, number is greater than 1 means 2, 3, 4, 5, that's thing, and when the number is less than 1 means 0.25, 0.3694, something like that. When the number is less than 1, in this case the characteristic is 1 more than the number of zeros between the decimal point and the first significant digit of the number, and it is negative. Negative number we denote in the log here, that is 1 bar, 2 bar, etc. Now let's go to the example. Here the example I can see, first one, the number is 654.24. Now 654, so basically it is 3 digits. 4 is 1 digit, 5 is 1 digit, 6 is 1 digit. So before decimal point there are 3 digits, so the characteristics is -1. So 3 minus 1, that is 2. In the second example, it is 2 digit in the before the point, before the decimal, so the characteristics will be 1, because I am just subtracting 1. So in the last example, 8.3547, here the number before decimal, the total number of digits is 1, so 1 minus 1, the characteristics is 0. In next example, when the number is 0.6453, so after point the number is coming, so the characteristics is 1. Here in the second example, 0.06134, the 6 is the first significant digit, and that is coming after 0. So the characteristics is 1 plus 1, that is equal to 2. And in the third example, that 0.00123, 1 is the first significant digit, and that is coming after 2 zeros, that is 2 digits basically. So the characteristics is 2 plus 1 equal to 3. You have to remember this, because some of the joint entrance examination there is a special math which sometimes comes, find the value of the log, like how many digits are there in the log, something like that. So there we will use these types of formula. Mantissa is the decimal part of the logarithm of a number called mantissa. For mantissa, we look through the log table. So log table we will not discuss because I have not seen this log table things in for the last 10 years or more in the joint entrance examination. So let's forget about the log table. So that's Mantissa. Thank you. Thanks for watching my video. I think now we will close the theory portions of the logarithm. Actually theory portions can never be closed, so somewhere we have to make it close, because after that only the problem and solution portion of the logarithm we can start. So till now, thank you, and thanks for watching my video. If you like my video, please like on the YouTube or subscribe me so that it can be reached to wider audience. Have a good day.